Good afternoon, ladies and gentlemen, or good morning or good evening, depending on your time zone. I'm Kevin. I will be the chair for the session. And it is my great pleasure to introduce you to Radical Wahid, who will be making his presentation on optimize your database operations with asynchronous processing.
Okay. Okay, everyone. Today I would like to present to you about my talk. The title is Optimize Your Database Operation with Asynchronous Processing as well. Okay. Uh, little bit about me. I am an Indonesia guy. So I live in Asia. Now I'm working day to day as a data scientist in media analytic digital startups company, and previously speaks at Genome Asia Summit 2019, Python Conference Indonesia 2019, and Python Conference Asia Pacific 2020. You can find me on LinkedIn or GitHub by writing my username Wahid16. Okay, so the outline are database operation first, and then synchronous and asynchronous processing, and then why we need to optimize our database operation, and for database, asynchronous Python in database operation, and we can continue it to live demo, and for the last part, we come to the conclusion, and you can ask me about question as well. So database operations. Yep. So the database operations is set of the operation that allows you to do more than the CRUD, like create, read, update, delete data from the database itself. Yeah, it can allow you to do more than CRUD, like migrating database, backup database, and uh, yeah, and like that. And then the operation is expressed by a structured query language or like SQL. But the other part, you can do it with ORM. Yeah, when your program to a single query, it performs the IOpen operation, which means it refers to a condition in which the time it takes to complete a computation determined principally by the period spent waiting for IO operations to be completed. So in this sentence, I bold it the sentence like the period spent waiting for IO operation to be complete. This is uh, the main idea of this talk. So these are the basic core examples. You can create like database, table, insert data to your database, select specific data, update your data, and then delete your data as well. This is the basic query that I think the all of backend engineers know it as well. Okay. Okay, next move to synchronous and asynchronous processing. Imagine if there is chess master host a chess exhibition in which he plays multiple amateur players. He has two ways of conducting the exhibition: first synchronously and second asynchronously. The assumption: there are 24 opponents. He makes each chess move in 5 seconds. Opponents each take 55 seconds to make move. So, game average 30 pair moves, so the total is 60 move total. And if the grandmaster is play it with synchronous version, he just plays one game at a time, never two at the same time, until the game is complete. Each games say it takes 55 plus 5 second, multiply it by 30, which equal then uh, 1000 uh, 1800 seconds, or 30 minutes. The entire exhibition takes 224 multiplied by 3, which is 720 or 12 hours if the player using synchronous version of play chess. If the player or grandmaster using asynchronously, he will move from table to table, making one move at each table. And then he leaves the table and lets the opponent make their next move during the wait time. One move on all 24 games takes, say it, 24 multiplied by 5, which equal 120 seconds or 2 minutes. So the entire exhibition is can now cut down to 1 hour. So this is a difference between asynchronous and synchronous version. If we illustrate it as a chess play, and then if uh, it is look from database perspective, it will like this. If I have a query one that will executed at 9 p.m. and then the database give the data at 9:10 p.m. So there is the two minutes waiting time before the query 2 is requested on the database, and the result for query 2 giving that database giving back to me is 9 minutes, say it. So the total duration is 19 minutes. If we use the asynchronous processing, the process will look like this. So uh, we can straight execute the query 2 before the query 1 data is giving is before the query 1 data complete to to query from database. So the illustration is like this, and the total duration is 10 minutes. Yep. Okay, why we need to optimize our DB operation with asynchronous? First, synchronous DB operation is fine. It's just fine as long the IO traffic sent to the database are low or medium, depend on your use case, of course. And then the basic idea is how I can do the other things in my waiting time while I'm waiting the processes from the previous tasks are done. This is the basic idea of asynchronous processing. So if we optimize our DB operation with asynchronous processing, of course it can reducing the waiting time execution in your program if there are many I/O traffic in one time. The conclusion is the basically it will not make your code faster out of the box like while you using PyPy or Python. It is just use the waiting time to the other task in a single thread as well. So this won't make your code run faster. Okay. Nah, before applying asynchronous DB operation, you have to make sure that your query is optimized well. Yeah, sometimes because the bottleneck is in the query itself, not the operation. So uh, when when you when you need to refactoring your code or your SQL, uh, you have to make sure that your query is optimized well. If bottleneck still there, then I think you can use the asynchronous processing as well. Okay, this is asynchronous Python ideally. Uh, Let me show you how this code runs in my VS Code. Yeah, like this. So I have two function here. Ideally, this is a coroutine, which mean the function that any async in front of it, like this. So this is the coroutine. I have two coroutine, and this coroutine is have to run inside the single event loop. So if I run this code, it will produce the output like this. Hello, and then wait 1 second, and then it will print world. So what happens? Uh, the code in this is run asynchronously. So uh, the high coroutine will print hello while he wait for 1 second and then print world. This is the uh, async and this is the asynchronous code works. And why we not use time only? It's like this. If we use time, the code will blocking. So there are no asynchronous code. I mean, there are no asynchronous process, even if this code is run in in one single event loop. If we use time, it will blocking the operation like this. Uh, okay. Hello world. 1 second. Hello world. So this is if we run this code synchronously. So this is the basic idea of how synchronous or asynchronous code are works. Let's back into the presentation. Okay. So the coroutine is a function that have many entry points for suspending and resuming the execution. And the coroutine, if in code, is a function where there are any async word behind it, and then event loop is responsible for scheduling, suspend, or one or more coroutines simultaneously. So the illustration is like this, and you need to know, guys, that asynchronous processing is it is agnostic technique because you can do it in other programming language like JavaScript with Node.js, Golang, Rust, and etc. So event loop is single thread uh, like scheduler. So it is we will always check if the operation through file system, database, or computation is done, and then the result is uh, sent into the CPU who request it. So this is one block the process, and the illustration is just like previous my illustration on database, the database asynchronous. So how about asynchronous Python in database operation? These are these are libraries that you can do it in your daily coding journey. Uh, I am using daily using AsyncPG with some ORM like SQLAlchemy, and yeah, you can do it say asynchronous processing with SQLAlchemy since version 1.4. You can find it in the GitHub repository by TimeViewer. Okay, and then okay, uh, there is a blog. I mean, there is the article written by the creator of AsyncPG. I guess this is show you guys uh, that he can insert or do the operation with 1 million rows from Postgres to Python in just 1 second, and the result benchmark is like this. Yep. So the SmpG it can process almost 1 million rows in a second if compared with Golang and Node.js. But someone told me that you have to be skeptical about benchmark, and you have to try the benchmark your own. So uh, I think that is more justice. Yeah. So let's move into live demo. So I will make experimentation that uh, performing a DB operation, the database operation on synchronous code and asynchronous code. The first, I want to select data from one table, and then I insert the selected data with synchronous or asynchronous processing to the two tables. So there are two to insert process that it will run asynchronous or synchronously based on my previous illustration in my previous slide. And yeah, you can get the code in my GitHub repository, but it is not the complete code. So after the presentation, I will push it the whole code and on that repository. Let me move to my VS Code. Okay, first we have a database with two two table, just like this. It's just simple table which have one column. Let's just say the column is name and the data type is text. So the data is the dummy data I get it from the Pokemon data from the Pokemon API. So it will insert data only, not a complex query. So, like this. So I have this for reading the CSV data. I will do it asynchronously. This is the coroutine, and coroutine it have to await it if we want to run it. Okay, like this. I will drop tuple first if exists, and then I will create the tuples, and then I will insert the data to the tuples itself. Okay, this is the main idea of this code. And then I move to synchronous plan SQL that this code will perform the process synchronously. So first, we get data from from the database, just normal query, select all from users 0, and then uh, I insert it to the two database. So the code will be like this. It just a simple query, simple straight query. There are no async or await in this code as well. And then it will run like this. Let me comment this first. I will explain to you later. Okay. Yeah. So I will do loop for I guess 5 times, and we will see the result. So um, yeah, uh, if I want to insert uh, these rows, it will take 2 seconds to complete on a single on I mean a synchronous code. How it can optimize if we use asynchronous one. Okay, so the asynchronous the code is just like this. Uh, okay, okay, like this. So I used get data from previous module from here, get data from DB. Nah, and then uh, I insert it into same table, which are user 0 and user 1. But what it difference is this is I using async and await sentence in and await word in this coroutine, because uh, asynchronous code is run concurrently. So if we compare the result with with synchronous one, the result are different. Let's we start it. This so it will recreate the tuple. So the tuple will delete all the data, and then this is to run the asynchronous code with async IO. This is a single event loop, and then yeah just print uh just print the result. We start it. Let me save first. Okay, here. Okay. Asynchronous. Okay. Okay. Nah, yeah, this is the difference. If we compare the uh, database processing asynchronous and synchronously, if we insert like for like more than 14 14,000 rows, it will took 0.6 second if we use asynchronous SQL. If the synchronous SQL, it will produce a 2.5 second. Okay, this is the just uh, this rows. How about if we multiply row, say it uh, 7, this is 7. So the difference is also bigger than before. Let's just start it. Okay. Okay, just 1 second here. It took longer than the asynchronous. Yep. Yeah. Okay. This is the result. So the result is it is far different if compared with synchronous and asynchronous processing. Nah, this is that I want to share with you guys. If we can optimize our daily operation using asynchronous processing, then we can reduce the time execution as well. Okay. How about object relational mapping like SQLAlchemy? Well, it is just same like to code before. I just used it. Yeah, like this. I have defined my database model before, like this. Just simple, just simple table. And then if we run it, so the result will not. The result will not far away from the asynchronous the plain SQL text before. Okay, let 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 we try this module. This okay, seven times. Okay, let's run again. Yeah, we can imagine if this is only to process in this demo. What if our program have many query that we can optimize it asynchronous way? It will more optimized if we use asynchronous, or it will be backfire from us because asynchronous is actually is not easy. It have to maintain it carefully because yeah, because it give you the asynchronous order like that. So the result is not far away from the plain text SQL as well. So it's like this. Okay, let's back to the presentation as well. So this is this is the main idea of asynchronous processing in a simple way. Okay, so the conclusions that we can achieve in this talk. First, synchronous DB operations is perfectly fine if there are no high IO traffic in your program as well. And yeah, you can optimize the database operation with asynchronous processing if there are any high IO traffic. If there is not IO traffic, well, synchronous database operation is fine. Okay. Yeah, this is not all the third-party libraries in Python support with async IO, but many of them is rapidly growing on development because in my job, when I try to make whole thing asynchronous, it will won't work like uh hope for, but it's okay because uh from that experience we can make sure that we choose right tools for the right problem, or we can choose the right method for the right problem. Not all the things should run asynchronously. And then yeah, sometimes easy to understand is not equal easy to implement. If you want to use it in production, you need to truly understand your own data flow because it will not run synchronous as usual. Nah, this is the point. If we know that the we know that using asynchronous processing, it will make our time is uh, my time execution is reduced, but of course there are cost that have to pay, like your code is more uh, purpose, and the data itself is not coming and if I'm sorry, the data itself is not going to you synchronously, but it will uh, come to you synchronously. So yeah, you need to try to understand your own data flow. Okay, that is all from me. Any questions?
Thank you very much. That was a lovely, clear talk with some good examples. We have a few questions in the chat.
Okay.
Can you see them?
Should I stop my share screen?
Yeah,
Uh,
it's okay.
okay. I
Yes,
cannot see.
I think you
Okay.
stop sharing your screen and we'll should be
Okay.
able to see them. There we go. So, first
Okay.
question. Uh, what would happen if you perform two inserts asynchronously? In other words,
Uh,
I guess simultaneously inserts.
okay. If we perform the two insert asynchronously, so the first query is send it to the database, and uh, the second query is without waiting the query from first back to us, it will run. So there are no blocking code. Like let me share my screen again.
Okay.
Like this. I think this uh, I think this illustration is the answer. Yeah, this is what happen if we run to insert query to the database. So the second query it will not waiting like on the left illustration. So basically the technique is like this. I I hope it helps you. Thank you.
Yes, that's the main advantage I see from the use of async. We have another question. Do you also use performance measurements that use query plans to compare the improvements using the async method?
Do you also perform estimation that use script plans? Yeah, of course we measure our previous performance because the project manager or the product manager will not ask you to uh, do refactor or optimization if there are no bottleneck in your program. So of course we measure that the performance of our query, guys. If yeah, we 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 measure it using synchronous, asynchronous, or maybe in other hardware like parallel processing. multi-threading, uh, we also compare it.
I have a follow-up question myself on this. Is
Okay.
what would you consider to be a good way in a real-world situation to measure performance in these kind of situations? What would you use when measuring a production system?
Okay. When I measure it to production, uh, that we work as a team, right? So
Hmm.
there are QA engineer that uh, test our system. If our concern as a data team is to first time time consumption and memory consumption. If the time and memory consumption is less than uh, less than before, then we'll use it in production. And will, and if not, well, will not ship it into production. So I think that is simple measurement.
Yes, it always boils down to real-world time.
Yeah, actually, the real world project is uh, it's not always using asynchronous.
Yes,
It just fine. Yes, just synchronous way. But in some cases, that if you want to use asynchronous, then just do it like that.
we have a question on your example code. The example
Okay.
code was using async but seemed to be serial. Is the speed up just coming from the use of AsyncPG compared to the synchronous engine?
No, the speed up is coming from uh the speed up because you let second query run it. I mean you let with while using async and await, you can run the code concurrently. So the second query will not waiting from the query one is complete. I think like that. So there is not a speed up like you using PyPy or Python. It just using waiting time to order to do the other tasks. I think like that.
Okay, thanks.
Okay.
We have a follow-up question from LJ. Uh, I'm showing his last question. I believe this is
Okay.
the newest version of it. It would be interesting to see the case where you set the batch size on the execute batch method versus execute many method for asynchronous. You might be able to compare better.
Okay.
What do
Yeah.
you say to
This
that?
is
Yeah.
okay. This is a good question about execute batch and execute many. Yeah. In my work, we use execute batch because you know when we execute many, the process is heavy, so we have to execute it uh, batch because it is will consume your RAM. But yeah, that's the point. Thank you.
Okay, thank you. I have a question that has just occurred to me is, I mean,
Okay.
in these systems, you have a lot of hardware that's going to be providing. I mean, you have a server
Yep.
running the
Yep.
database and so on.
Yep.
Um, but we're looking at it from the software side of things. And
Yeah.
as you mentioned near the end of your talk, there's a lot of different async aware libraries in Python, but not all of
Yep.
them are fully compatible.
Uh, uh,
In in
I know.
in your experience, how did you find when you were looking at the ones that? How did you test them? What advice could you give a Python programmer who's interested in implementing async and when they're looking at these various Python modules?
Okay. From my experience, I say it because the documentation for in other libraries say it that it uh, it 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 do not support asynchronously. So yeah, from the from the documentation itself say that point. So we cannot force it run asynchronously. In our experience, I then I run asynchronous processing in Airflow 1.1 point. It's not 2 point. Yeah, that is throw you an error because the Airflow, when it trigger your code, when your code is any asynchronous program, it won't work because actually the Airflow, based on my knowledge, it is built from Flash, and Flash run in top of the unicorn, so you cannot perform the asynchronous processing at that. So my advice is read the document well, because in the documentation, I mean documentation, uh, it it provides the full information to you. So before trying or make new experiment, I advise you to read the documentation carefully, like that.
Of course, that's a good suggestion. And also testing, doing a benchmark, as you've
Yeah,
demonstrated, because some implementations might not be as efficient,
yeah,
uh,
that's true.
or are not mature enough yet.
Yeah, that's true. So yeah, that's true.
Well, thank you. We seem to have come to the end of the questions. Are there any other comments you would like to make? Perhaps where people could look further if they're interested? Um, uh, anything that you didn't mention because you wanted to keep within time? Because we have a couple more minutes.
Okay. Actually, that I want to say is everything is not have to run asynchronously, because any because some people we say it that everything must run asynchronously, everything must run parallelly, but that is not the solution of all problem. So choose right tools for the right problem, or choose right methods for the right problem. That's it.
Thank you. Well said. I often like to advise new programmers, don't rush in with a new method because it looks
Yeah,
very
yeah,
interesting.
that's true. Yeah, new feature or new cool feature, it won't go it it won't going to production fast, because there are any quality from the program that we have to keep it. So
Thank you very much.
okay, thank you.
That was a very interesting talk and well done. Uh, thank you to the attendees, participants, and thank you for the questions. They were interesting. And of course, thank you to all the sponsors of PyConZA. I think there's just one announcement to make. There is a replacement talk after the break in the second video streaming. So starting at 15:45, we now have a talk on neural profit, a powerful AI framework for time series models. I think that's the only change to the program at this stage. Um, anyway, thank you, everybody. Thank you again to the speaker.
You're
I thought there
welcome.
was a sound that I could play of clapping. Oh, here we go. Thank you very much.
Thank
Thank
you,
you,
thank you.
everybody. Goodbye, everyone.
Bye.